this problem we have this equation, and we're asked to find dy dx. So we're going to use what's called implicit differentiation because we have a y squared here, we have a y inside the cosinh, so it's going to be pretty hard, if not impossible, to solve for y. So in order to find the derivative, what we'll do is we'll just take the derivative of both sides with respect to x. So I'm going to indicate that by writing d dx of all of this stuff here. So I'm going to write it again, y squared plus x cosinh y plus, and then this sinh squared of x, this is shorthand, so I'm going to write it another way to make it easier to differentiate. This is really sinh x, and then this whole thing is squared. So that's the derivative with respect to x of the left-hand side. And then we want to do the same thing with the right-hand side, so d dx of 50. Okay. So this derivative here in the middle is going to require product rule, so I'm going to write it up here just as a refresher. If you have f times g and you want the derivative, think of f as your first function and g as your second, and the formula tells us it's the derivative of the first times the second plus the first times the derivative of the second. All right, let's differentiate this. So we're differentiating with respect to x, and we have y squared. So really y here is a function of x, so we have to treat it as like a function of x, and we're using the chain rule. So we bring down the 2, so you get 2y to the first power, I won't write it, times the derivative of the inside, which is dy dx, right? Chain rule, right? Remember, y here is a function of x. We're differentiating with respect to x. So you bring down the 2, you leave the y alone, right? That's the inside function. I'll go ahead and put the 1 there. And times the derivative of the inside, which is just dy dx. Here, for this second term, we're going to use the product rule. There's our f and there's our g. That's our first factor, that's our second factor. So plus, it's going to be the derivative of the first, which is 1, times the second, which is the cosinh of y, plus the first, which is x, times the derivative of cosinh, which is simply sinh y, times the derivative of the inside, dy dx, right? Remember, it's cosinh of y, so when you differentiate it, you do have to multiply by the derivative of the inside. If it's cosinh of x, the derivative of the inside is just 1, because dx is 1. So it's because there's a y there that you have to do this. Plus, here we use the chain rule again, bring down the 2, so we get 2 parentheses sinh x as to the first power, and then times the derivative of the inside. The inside function is sinh, its derivative is cosinh. And then on the right-hand side, things get better. 50 is a constant, so its derivative is 0. All right, we're looking for dy dx. So there's one over here, and there's one here. So let's factor that out. So dy dx, so 2y plus x sinh y. And then let's subtract away this term here and this term here. So this is equal to negative cosinh y, and then negative 2 sinh x cosinh x. This is an identity, by the way. This is sinh of 2x, I believe, but we don't have to do that. I don't know why I divided there. So in the next step, all we have to do is simply divide by this piece here. So the final answer, right, we'll divide everything by, I'll show it, I guess, 2y plus x sinh y. And then same thing here, we have 2y plus x sinh y. So the final answer here will be dy dx equals negative cosinh of y. And I mentioned this was an identity. Let's go ahead and write it that way. So 2 sinh x cosinh x is really sinh 2x. This is minus sinh 2x, kind of an optional step, over, and then we have 2y plus x sinh y. A little bit more work on this one, but not too bad. Not too bad. I hope this video has been helpful to someone out there in the world. Good luck.